Hello there, and welcome to Life After Fall Break. I want to produce a video to go over Module 6. The title of Module 6 is Hypothesis Testing. And there are a few things I'm hopeful that will start to emerge for you as students. We've covered a lot of concepts to date, and in my own learning as a statistics student, this was where things actually started to make sense. It was like the light bulb got screwed in. I was, in full transparency, a B and C in algebra student, a C in college algebra student. I didn't care about math. I didn't care at all because it was like, how does this apply to anything I'm going to do? And so I had a lot of trepidation as an undergraduate student when I took an upper level stats class in psychology. I had the anxiety, the butterflies, am I actually going to pass this class kind of thing. And so I paid attention, and I bought the graphics calculator that was necessary back in the early 90s to work through all of the complex formulas and finding all of the standard deviations, the square roots, all those, the variance, calculating, finding these very sophisticated and multi-step formulas, working through them, making sure I inputted everything just right, hit the right button on the calculator. Did I did I do a graph the correct way? All those things. I was a little, I was frustrated. But then one day we started talking about hypothesis testing. And that's when the light bulb got screwed in and the light came on. And I got an A in my stats class. I got an A because it was like, this finally makes sense. And it comes from, I'll go back to this book. It's published probably in 90 or 89 or something. We used to teach this class with this book here. And there are a million stats books out there. If you start to become a doctoral or master's student, it would behoove you to find a statistics or research book that specifically deals with your area of research, whether it's multiple regression, whether it's some type of qualitative data analysis, whether it's ANOVA, ANCOVA, MANCOVA. I mean, you can go on there. There are certain textbooks that are better than others. This was not, SPSS wasn't really a thing. I think it probably was, but I didn't use it. And it was this, me and my Texas Instruments TI-81 Plus. So let's go into formulating a null hypothesis and alternative hypothesis. That's one of the main goals for learning this week. So if you're formulating a null hypothesis, we actually formulate a null hypothesis. And why not just formulate a hypothesis? Because in science, we want to hedge against our own biases. When developers of scales, when people are trying to develop a medication that can help a disorder, we have a lot vested in, okay, we want to see that work. And so in science, what we do is we give ourselves a minute chance of being wrong. In other words, we want to bet against ourselves 95% of the time. And if we are going to see an effect, we want a 5% chance of being wrong, so to speak. So when we set an alpha level, an alpha is generally looks a little bit like a fish, but it is let me show you here. If I had it on the top of my head, but I don't. But I do have this. And if it'll show up. And so what we have is we're going to have some hypothesis testing. And we want to minimize our possibility of making a type 1 error. In a type 1 error, we are stating that there is a true difference in scores, and it's our real hypothesis, right? We're stating that there's a true difference in scores when in fact there is not. That's a type 1 error. So we don't want to have a type 1 error. Oftentimes we set alpha or the level of significance at 0.05 where our statistical findings are significant. Other times, if we really want to hedge our bet against ourselves, we might set that at 0.01, which is 1 in 100 chance that these findings occurred by chance, by random. In other cases, we might want to really set the bar high, where it's 1 in 1,000 chance where we found this significance in our statistics by error, by a random chance. In other cases, we might just want to give our 10 like a 0.1 level, set alpha at 0.1, where there's a 10% chance where we have a type 1 error. A type 2 error, and so P, you can see alpha in this P, our P value will be our alpha value. And P, if you think about that, think about P also being significance. So when you see this in the statistical notation, we'll have a few exercises like interpreting what these Greek symbols are and what the stats are saying. You'll have a couple of assignments like that. But thinking about this, move over to this page. And this is how I learned it, and so it sticks with my mind still to today. So basically what we're saying is and this is a group of fifth graders that were taking a standardized test. And so this group of fifth graders that took a standardized test, they took it, and there were 64 of them, and that's what the distribution looked like. So most of them, you can see, scored around 200 on the standardized test. The standard deviation looks like it's 6. And so the z-scores, you can see the z-scores along the bottom there. You know, it's like a standard distribution. So most people scored around, 1 or 2, or excuse me, 1 above or 1 below standard deviation above the mean. So if you were going to interpret that, you'd see that 68% of the students scored between 206 and 194. And so then you see that fewer students scored very low, down to -2 standard deviations away from the mean. They're relatively few, and really few that were, 3 standard deviations or below. And same thing here. If you look at the upper end of the distribution, you see that around, let's see here. What's that say? 209.84. So the 95th percentile on this test is 209.84. 95% of students scored below that. 5% of students scored above that score on the standardized test. So that was our control group. Our control group, if we were running an experiment, that was our control group. So again, it was fifth graders taking a standardized test. Now, we're doing an experiment, and our experiment is saying, we think we have some specific instructions that can significantly, and that's a key word, can significantly increase fifth graders' score on this standardized test. So we have our control group where they go and they take the standardized test as usual. Then we have our experimental group, and we give them this very specific instructions about how to take the test, about how to answer the questions. We don't give them the answers, but we give them instructions about how to take the test. And then we compare those students' scores. So hypothetically, let's say that we now give the same test to 64 other students. And this is what we see. We see that now the mean for this test, for the students taking this test, there's the control group, here's the experimental group after they got the special instructions. Now the mean increases from 200 all the way up to, I would say that mean is, it's not 209.84, but it looks like it's around 208 or so. if you were looking at that mean, if I were reporting the mean, it'd be about, oh, come on, focus. It'd be around 208 or so. So instead of 200, looks like we've on average increased those test scores 8%. So we can see we've moved this by giving them instructions, and we compare the original sample with the experimental sample, there appears to be some movement. So now, if we're calculating power, statistical power, we can see that we can with some, some certainty, and that we've increased the number of people that are what? Above this alpha line, this alpha level of 0.05. So this is where we start looking at statistical significance. We start looking at power, the change in mean, the change in shape of the distribution. So in this case, we do have two normal distributions that can vary a bit. But this is where we start applying all these. Why did we go to all this length to learn about normal distributions, to learn about, standard deviation, so you can actually see if there's a benefit and how many people that a change in a condition in an experiment could benefit people. So I'll stop there. I know I've gone over quite a bit, and I'm going over in broad brushstrokes, but again, when you get a visual and see why we do what we do with our statistics, it can be helpful. So I've got another person trying to enter my meeting. I've got an advisement meeting, so I'll continue this.